go ahead and add the remaining portion. So I have mentioned all the columns. Now we say na.rm is equal to true. Okay, so that specifically means that don't remove an na is true, right? So you are trying to remove and not applicable, and then it's going to enter. It says that okay, we have changed few of the column names, so it's not found over here. So let's check what are the names in company first. Okay, and then we'll just edit this. So executive ID, okay, this has become executive ID because we have changed the column names and this has become test date. So I have to mention that as a test date. Country remains as it is, gender is as it is, age is as it is, and then we're going to say and enter. So now it should be fine. Now you can have a look at new data. Okay, so this is the conversion from a 5 set record. It has got converted into so many records, right? Fine. So you can now use it for the cast operator as and when you require, right? So let's go ahead and do that. So next is where we are going to use the cast operator. So basic form is that you can say cast and you can just mention the data. So the data in our case is new data, right? And I can say country country, and the tilde sign is for the variable on which you want to do it, and you can say over here that what you want to do, whether you want to compute a mean and all those things, you can do so. And if you want to allocate this to some object, you can say country means, right, and save it over here. Okay, there's some warnings because I've done something. Let's have a look. Country means, okay, it's not applicable. What we'll have to do is we'll have to just go ahead and do this again, but so let me take a subset. Instead of doing it on company, I'll do it on company 1 because we haven't done the conversions over there. Look at company 1. I have to just remove these two. So company 1 is company 1, and I'm saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm saying remove the 11th and the 12th one. Okay, so yeah, this makes a little bit of sense. Let's do new data again. So these columns are there, but with a little bit of change. Test ID, test date, country, gender, age, remove NA. Okay, now this looks tidy, and then I'll use the cast operator. So I'm just bringing back the same code which we had used, and country variable mean and country means, and so this is how we will get the data. Obviously in the previous case it did not work because we had some transformation wherein we had added 2 more columns in the end which were categorical, and you cannot get mean of a categorical variable. You can get a mean only of a numerical variable, and that was the reason why it happened. Okay, so now it is sorted. So now based on the country you are getting averages for u1, u2, u3, u4, u5. So this is how you use the melt and the cast operator. Let's move ahead. Now a lot of time in this specific function you had said na.remove. You had removed the na value. Why? Because an na cannot be mathematically operated, so you cannot do a computation on an na value. If you use some mean value, mean function, any function in R or anything else, the na typically doesn't participate in that, right? You cannot even check whether it is greater than something or less than something. You can just have a look at this, right? So how do you actually isolate this NA, right? So there is an inbuilt function called is.na, which basically gives you a boolean value true or false, specifying where exactly is an NA applicable, right? So I can just run that is.na function on company, right? So it's wherever you can see a true. So under age, so fifth observation, age is showing a true, and similarly for age category, it's true. That means there is an NA applicable over here, right? So that's what is a helpful function which helps you isolate the NA. Okay, let's move ahead and work a little bit more on the NA as to how to do it. So basically we would be doing something called as a recoding of values, right? So we say company dollar age, right? Now this is something which we have already done, right? So if you just look at data, let's have a look at the data company, and we can say that this was the column which had a 99 entry, and we had changed this to any long time back. Now if you try to search for this again, it doesn't make sense because there is no entry called as 99 over here. So we'll just go ahead and do some more processing on this data. So what do you want to do when you see an NA value? Depends on how much proportion of the data is not applicable. Say 50% of the data is not applicable, and if you just omit all the data, it doesn't make sense. You'll have to go back to the root cause of the NA, isolate whether there was a data import problem because of which some of the values were not captured, or something in the code which while you were processing actually converted that to an NA value by mistake. And if you find it reasonable to drop the data or the rows wherein NAs are present, then you have a function called as na.omit, right? So you can just use na.omit. So I'm saying new data allocation na.omit, right? Now what this function does is it isolates whether there is a not applicable in any row. If there is a single column which has an NA value, it will drop the whole row itself, right? So you have to be cautious. So maybe there could be Cartesian wherein there could be multiple columns which have NAs present in different rows, and if you just remove, you might have very sparse data left, right? Use it with some caution. So I'm saying company, so if you say na.omit, and then if you say new data, so the data set has been reduced to 3. Reason being that 2 of the rows had some NA values prior to this, and once you have done that, it has just eliminated all the data, right? So that's what we are seeing over here. Now we come to merging and concatenation of data sets. Now ideally this thing should be done in a platform like an SQL or something like that, but nevertheless it doesn't mean that R doesn't have a functionality to do merge and concat, right? We do have it. So we do see something like an inner join and an outer join, which is applicable on similar lines to what we do in an SQL based syntax language, right? So we'll have a look at that. So if you can see on the screen, so we are not doing it actually, you can directly see it. So what we are seeing that there is a data frame. So we are using 2 data frames, data frame A and a data frame B. And when we say the merge function, and I'm trying to allocate that to a total object, right? So you're basically extracting something from data frame A, data frame B, and you are using the common key like a primary kind of stuff by ID, right? So in our previous data, we can say company has an executive ID. Say you have a master data table wherein the employee data is stored separately, right? It's a master data. This is a transaction data. So obviously when you're merging these two, you can use merge. First object could be company, and the second could be master data for executives, and you can use the common key as executive ID, right? Wherein it will merge both of them, right? Similarly, you can do it by 2 columns also. So you can have an ID also, and you can have a country code also. So that's what we are seeing in the second line of the code, right? So, and that's how you do a merge basically. Now there are different ways in which you could merge. So if you traditionally see, there is an inner join, there is an outer join, left outer join and right outer join. So all those guys who know basically SQL would relate more to this. Now how do you do this when it comes to R? The syntax remains roughly the same. The only thing is that the by column changes. Now to make this more relevant, I would like to show you the syntax in something like how do you use it, right? So you have the merge, right? So you have the X, that is you have to specify first data frame, So I'm just saying test, although I don't have any data like this, and then I say y. So I'm saying test1, right? And after this you have to specify by, right? So you can say by, and you can specify by which key. So you can say by id or something like that, right? And then you can also specify, there is one more option, so you can say by dot x and by dot y, that is also possible. And later on you can specify a final thing, that what do you want to retain. So when you do a left outer join, you basically want that the table which is on the first, the left table, you need to have that as the basic frame, and anything which matches in that from the right table should be populated in the left table. That is what is the basic meaning of a left outer join. Similarly, it goes for the right outer join. A similar application you would see somewhere when you're doing a VLOOKUP also, right? So different tools use different ways of doing the same thing. In essence, you should ideally understand what are these joins. That is where it makes more relevance, right? And the all dot x basically says that, so if you say an all dot x is equal to true, that means you are saying that this is a left outer join, and all dot y is equal to true, that means it's a right outer join. You have to use x as the first data frame, y as the second data frame,